Hello, my name is Mark Gibson, and you're listening to the podcast version of the Teagasc Signpost Series, a weekly webinar that promotes and examines sustainability in Irish farming. A very good morning, and you're welcome to today's Signpost webinar. Today we're going to be talking about Ireland's hidden peatlands, and we know that the peatlands play a crucial role in Ireland's environment, acting as carbon sinks, supporting biodiversity and influencing water management. However, they are also at the heart of important discussions on agriculture, climate change and land use policy. And today we're delighted to be joined by Dr. John Connolly, who is a physical geographer and geospatial expert based in the Department of Geography in Trinity College. And we're also joined by Dr. Keena, who's a countryside management specialist with Teagasc. Good morning, John and Catherine. How are you today?
Morning.
John, you're based in Trinity, working in the area of peatlands and obviously the geospatial area as well. Could you tell us a little bit about the work that you're doing there?
Yeah, so I've been working in peatland research for about nearly 25 years now. My work predominantly focuses on mapping peatlands and then looking at the condition of peatlands over space and time. So I've been working recently on some very interesting projects where we've actually gone back to the 1800s. I'll present some of that work in the presentation today, where we're looking at the bog commissioners' maps. Those maps were very accurately measured by chains. So they're a really good baseline of the spatial extent of peatlands before widespread degradation by board and ammonia, etc. So I'll present some of those results today. Also looking at land use and land cover on peat soils throughout Ireland. We use all types of remote sensing, so drones, satellites, airplanes, to gather data that we can then analyze and assess different features on the landscape. So one of the projects was looking at mapping drainage on raised bogs in the Midlands. In that project, we were able to identify 20,000 kilometers of drains in the Midlands. So it's really, really useful for providing data to land users, our MPWS, our board and ammonia when they want to identify drains to block and all these different elements as well. Yeah. So my background is in geography. I did a degree in geography in UCD. I did a master's in geography in the UK, and then I came back to Ireland and I did a PhD in a geographical area, but it was actually in biosystems or ag and food engineering in UCD at the time. So I actually have a PhD in agriculture, but it's really focused on geography and mapping. So my presentation today is Ireland's hidden peatlands, a geographical perspective, and I'll be looking at peatlands in Ireland from that perspective. So just to give you an overview of peatlands, I think many people know this, but just in case you don't. So peatlands are a very large carbon store globally. On a meter for meter basis, they store more carbon than any other terrestrial ecosystem. Globally, they contain about 25% to 33% of total soil organic carbon stock. And this is only on a very small area of about 3 to 6% of the land area. When they're degraded, they also emit large amounts of CO2, and peatlands that are degraded globally are responsible for about 5% of total greenhouse gas emissions. So if you compare that to like the airline industry, they're responsible for about 3%. So when peatlands are degraded, it has a massive impact on greenhouse gas emissions. So in Ireland, during my PhD and in the time after my PhD, I worked on mapping peatlands, and in 2009, myself and Nick Holden from UCD produced a peatland map of Ireland called the Derived Irish Peat Map. In that peat map, you can see it there on the left-hand side of the screen. We mapped raised bogs in red and blanket bogs in blue and green. And we mapped them to we figured out there was about 1.46 million hectares of peat soil in the country. We knew at the time that was an underestimate because there were certain areas that we couldn't get to ground truth it to make sure that there was peat there or wasn't peat there. So in 2024, up to 2024, 23, 24, we worked on a new map called the Irish Peat Soil Map. And in this, we identified 1.66 million hectares of peat soil. Now, the definition that we used for that peat map was slightly different from the earlier peat map. In 2022, the UN Environmental Agency, or the UN Environmental Programme, produced the Global Peat Assessment. And in that, they said we should be including shallow peat soils in our calculations because they contain large amounts of carbon. So an area, if you have a hectare of peat soil that's 10 centimeters, it contains between 150 and 350 tons of carbon per hectare, which is equivalent to very high nature value rainforests. So we decided to include these shallower peat soils in our peatland map. So there are the deeper peat soils in there, but also the shallower peat soils. So that's one reason why we're seeing this increase in the area of peatlands in Ireland. We think we're missing about 100,000 hectares still. So there's further iterations of this map that we'll be trying to incorporate that data into. So in Ireland, like the global figure, the peatlands are the largest stock of soil organic carbon. Somewhere between 70 to 75% of the soil organic carbon of Ireland is stored in peatlands. Renew Wilson in 2022 produced a number that said there was 2.2 billion tons of carbon stored in peatlands. And on the right hand side, you can see work that myself and Nicole are working on to model peat depth and carbon stocks in blanket bogs. So you can see quite clearly on the west coast there that there's very high levels of carbon storage in those blanket bogs. So the more purple data is 3,000 plus tons of carbon per hectare. In terms of, and once we found out kind of the spatial extent of peatlands, we were able then to look inside that area and see, well, what is the kind of land use that we see on those peatlands. I do this using satellite data. In Ireland, we have an issue with satellite data in that we have clouds, so the satellites cannot see through the clouds. So in this map here, you can see that along the west coast, there's areas that are kind of hatched out with red hatching where we couldn't get cloud-free data for 2005. So that's a real issue that we're working to overcome, or we have worked to overcome. So in that map there, you can see that there's grassland on peat in green, there's forest on peat in yellow, there's industrial peatland like Bord na Móna in red, and then there's what we call residual peat, which is everything else. So those areas have undergone land use change, but we just can't see them on the spatial resolution. And I'll talk a little bit more to that later on in the presentation. So the kind of land use you see is forestry in the uplands. That's kind of our residual peat image there. The large scale industrial peatlands and grasslands on peat soils as well. So when we move to higher resolution imagery, we can actually see more detail. So this image here is a Landsat satellite image at 30-meter resolution. And this is a much higher resolution data. So I think it's half a meter. So you can actually pick out more detail in the landscape. So one of the reasons I put together this kind of talk was because the National Land Cover Map was published in 2023. And on the National Land Cover Map, peatlands came out at about 6% of Ireland. So we know that that percentage is much higher in the mid-20s, potentially, or low to mid-20s. So we're like, well, what's going on? Why is the National Land Cover Map coming out at a very, very different number? And one of the reasons is because peatlands have undergone widespread land use change over the last 200 or 300 years. So what we worked on was we decided we will do an overlay of our Irish peat soil map, which looks at the peat soil underneath the land cover and the land cover map, and we'll see what kind of land cover is hiding our peat soils. So we went through this process. So we were interested in this, this 17% difference between the 6% on the National Land Cover Map and our 23.3% on the Irish peat soil map. So we did a process, a geospatial process where we basically just overlaid the maps to look at what the spatial extent was. So how I describe this process to my students is, um, it's a cookie cutter process. So basically, if anybody in the audience has ever made gingerbread men or biscuits or anything like that, you roll out your dough and then you use a cookie cutter to cut out your biscuit. And it's kind of very similar process here. So in effect, our dough is the national land cover map, and we're using the shapes of the peat areas to cut out the areas of land cover that's on those peat. So then you end up with a map. There's effectively this map here, which is land cover on peat soils. So this is some preliminary work. It's currently under review. The paper is under review. Um, in this paper, we sought to bring together the peatland community and some researchers from different organizations like Teagasc to really have um, a good consensus on this work here for peatlands in Ireland. So we're hopefully that'll be published in the next year or so. Well, this year hopefully. But you can see the different kind of land covers. So there's peat land covers that are like the blanket bogs, the raised bog, fens, cut over peat, and bare peat. And then you see there's other land cover types that occur on the peat soils like grasslands, forests, heath, scrub, hedgerows, and then there's other ones as well. Um, Unfortunately, we don't cover Northern Ireland because the funders don't pay for that, but hopefully in the future we'll have an all-Ireland map. So when we drill in a bit more to the detail, we can look to see, well, what area of land use is on peat soils or land cover on peat soils. So we can see that wetlands cover about 250,000 hectares. Improved grasslands are about 230,000 hectares. Blanket bog is in there with about 220,000 hectares. And you can see all the way down that chart there that there's all these different land cover types that occur on peat soils. We also compared the data with the earlier map as well because we were interested in that as well to see how that changes over time. And we can see then when we compare and we can look at grassland on, for example, one of the areas we were interested in is grassland on peat soil. And we can see that because our area of peat soil has changed in the recent map, that our total number has changed. So we're looking at over 500,000 hectares of grassland on a peat soil. Okay, so one of the ways that we monitor this over time is we use satellite data. So this is some work that my PhD student completed in 2023 as part of his PhD. So if you remember earlier on, we had a real issue around the cloud cover. So what Wahash did is he went back and he used a online cloud-based geospatial system called Google Earth Engine, where all the data is stored up there in the cloud, and you can do the analysis in the cloud, which is really, it's groundbreaking for us because in the past we would have had to like basically email NASA and said, can you send me this image? And it would come as a CD and all the messing around that, or it would come as hundreds of CDs, whereas now we can do everything in the cloud. It's fantastic. But you can see on the left-hand side, the map there is changing. So we can see there's 1990 there, there's 2005, and there's 2020. So in order to get that clear sky image, so we could do the analysis, we had to take 3 years, so we had to take 1989, 1990, and 1991 in order to get enough clear sky data, because cloud cover is a real issue in Ireland. But you can see that it's quite dynamic. We're seeing quite dynamic land use changes on the peatlands. And particularly if you look to the west up in Mayo, there's a red area in 1990, and by 2020, it's changed more or less to the residual peat category. And that's the Bellacorrig power station. So Borden and Mona were mining those peatlands. And then in 2003, they stopped that process. And you can basically see the change that has come in that area there. And then throughout the country, you can see other changes as well. So, well, why is it important to look at land cover on these peatlands? And the main reason is because land cover change affects both the carbon stock and the carbon dynamics. So the carbon stock is the carbon that's stored in the soil, it is the soil, and the carbon dynamics is related to how well the carbon is sequestered from the atmosphere and stored in the soil, and how the carbon and carbon dioxide is maybe released from the soil. So when you change the vegetation on a peatland or on a peat soil, it impacts on the ability of peatland vegetation to sequester CO2. So if you drain a peatland and you change the vegetation on it, it's less likely to take CO2 out of the atmosphere and store it in the peat soil as carbon. And this affects the ability of the peatland to maintain its carbon stock over time. So the image here is I can't remember of the actual name of the post, but it was put down in the Fens in the UK. And basically, I've tried to kind of show that when the post was put down into this soil, this peat soil, in probably the 1890s or something like that, and where you can see it there today, that you can see this about 1.5 or 2 meters nearly of that has disappeared, it's basically decomposed out. So we had a project that was funded by the Department of Agriculture called Repeat. Um, and I'll just go to this slide first that kind of just talks about the land cover as well. So this is where we're looking at the land cover and we're saying, well, if we're just looking at what's on the top and we don't take into consideration the soil below in policy, then we can run into issues. And the reason why that is because land cover effectively hides the peat soil. So if you walk out, we can walk through the Midlands or we can walk through in the upland areas and we can see forests and we can see grasslands. And in those areas, when these large-scale national land cover mapping exercises take place, all they see is the surface. So they see the forest and they see the grass and they see the other land cover types, but they don't necessarily see the soil underneath. And in areas where it may not be understood that there are peatlands or peat soil, these may be missed. So I found that this was a very good diagram to kind of illustrate this point, okay? Because I was talking to this about policymakers in the EPA and the Department of Environment and the Department of Agriculture. And I was saying you need to take into account the peat soils in any decisions you're making about land cover, if there's different types of land cover on those peat soils. So for example, here, it's an example from the Amazon rainforest, where you have above ground biomass and you have a mineral soil, and it's in tons of carbon per hectare. So the above ground biomass is about 150 tons of carbon per hectare, and the below ground in the soil is about 100 tons per hectare. But if we move into a mangrove system in the Amazon, where it's basically a peat forming system, the above ground biomass is about the same. It's about 150 tons of carbon per hectare. But because the peatlands below are storing that carbon over time, over thousands of years, we get a buildup of carbon in the soil. So in this case, we have about 350 tons of carbon per hectare. But if we take that idea and we apply it to Ireland, and in this particular case, it's going to be applied to upland blanket bogs. In the first instance, this is in Wicklow. So in Wicklow, the peat bogs are anywhere between 1.5, well, they can be any range, but they're an average of about 1.5 to about 2 meters deep. So when we look at that and we look at the carbon storage associated with that, the vegetation is very, very low. So that green line is actually kind of exaggerated because otherwise you wouldn't see it. So the amount of vegetation, the amount of carbon stored in the vegetation in terms of tons per hectare is quite low. But in the soil underneath, we have huge amounts stored in the soil. So we have anywhere between 625 to 875 tons of carbon per hectare. And then if you apply it to those deeper peatlands that I showed at the start of the presentation, mainly in the west, so you have peatlands that are deeper than 4 meters, you start to see these kind of patterns here. So the deeper peats store huge amounts of carbon, so about 3,300 tons of carbon if you're deeper than 4.5 meters. And the land cover there is completely not representative. It'd be only a tiny sliver in comparison to the amount that's stored underneath, the amount of carbon that's stored. So it just illustrates the point that where you have deep peat, you need to understand that, and you need to understand the impact that drainage will have on that peat, or management decisions around if you have a land cover type on top of that. It'll have implications. If you're making decisions just on the land cover, it'll have implications for the carbon that's stored below in the peat soil. Okay, so a little bit of repetition there. So what I'm really interested now is how do we monitor this over time, so that we can monitor this over the long term, or we can monitor it over the short term. So we were very lucky to get access from the National Library of Ireland to the original maps from the Bog Commission from 1809 to 1814. In looking at these maps, we realized that they are actually really, really accurate. They were all chain measured, so as accurate as you can get without using GPS. And you can see the areas that were mapped across the country. So mainly across the Midlands, they were interested in peatlands that were greater than 500 hectares in size. So mainly across the Midlands, but also down in the southwest and also up in the north as well. So in this project, this repeat project, what we decided to do was to take these maps, all these maps, and to digitize them in the first instance, and then to geo-rectify them. So these are flat paper maps, but we wanted to get them into our online system, into our GIS system. So on the left-hand side there, you can see one of the maps that has been geo-rectified, so it aligns up perfectly with the landscape in reality. And then in the middle, we have the spatial extent of all the peatlands, all the bog commissioners' maps. And then on the right-hand side, we have an example of the bog commissioner's map from 1809 or 1810, and then the condition today. So the blue line basically outlines the spatial extent of the peat soil. So it acts as a baseline before we have this degradation. So on the degradation of the actual peat land. So on the right-hand side, then you can see there's grassland on peat, there's board and cutting on peat, there's forestry on peat. So it really gives us a good indication, one, where the peatlands are, and two, what kind of activities, what kind of land use changes happen to them over that 200-year period. We've done extensive ground truthing in the field. So we've taken boundaries to go perpendicular across the blue line so that we can figure out how accurate those maps were. And it turns out that they're actually very accurate. So this is how we know they're accurate, because we've taken hundreds of these accuracy assessments on the ground, where we've gone out and basically cored the ground and see where the boundary of the peat actually is nowadays. And this gives us these statistics that are very, very, very strong. So the median value was 18.5 meters. And if you just go back to this image for a second, the blue line in that image is probably about 50 meters wide. So our margin of error is smaller than the line in the image. And this is a really good little animation that I use to show the spatial extent of land use change on our peat soils. So the green line represents the extent in, say, 1809, and then the blue line is the kind of extent of the peatlands today, and everything in between is land use change. Okay, and here's another example, and I've been down to this area down near Monasterevin. It's Umaris Bog, and I've been lucky enough to meet several farmers down in this area, and we were very curious about this particular map because in 1809 it said grass on bog. You can see that just in the middle above the tunnel, just in do I have I don't have a mouse. So grass on bog, and we were like, okay, so these peatlands have been undergoing change for a long time, potentially more than 200 years. We wanted to go down to that particular farm and go in to see what was going on that. So it was grass on bog in 1809, and it's grass on bog today. We were interested in, well, how much of the peat soil is actually left? So we went to this particular farm, met the farmer, went out to the middle of the field, put down a core, and there's about 2 meters of peat still left there. Um, so that was kind of a shock to everybody that there was so much peat still there after 200 years of management. Okay, so I'm gonna move on a little bit. So I've started to talk about how do we monitor our peatlands in the long term. So those older maps are really, really useful for us. But how do we monitor it these days? So when we're monitoring it these days, we use a combination of satellite data and on-ground instrumentation. So we have eddy covariance flux towers that measure the amount of CO2 that circulates in the system, how much is being absorbed into the ground and how much is being emitted into the atmosphere. We use dip wells to monitor the water table. And then we use these satellite data, our spatial data, to look at what the peatlands are doing. Now, with the satellite data, we can get lots of different satellite data, and there's tons of data out there. It's really amazing now. These amazing free data sets from NASA, from the European Space Agency. But many of the images are on different spatial scales. So I just want to kind of talk through that because it does make a difference of what you can monitor at the different spatial scales. And each spatial scale has an advantage and a disadvantage. So you can see here on this picture here, there's several boxes of different sizes. And what I've tried to do is make those boxes the size of the pixels in the imagery. Okay, so at the red box is MODIS 500 meters spatial resolution. The blue box is Landsat at 30-meter spatial resolution. The yellow box is Sentinel at 10-meter spatial resolution. And then we're zooming right down to the green box is high spatial resolution satellite, so anywhere between 50 centimeters and 3 meters. And then the final one, well, nearly the final one, is aerial imagery at 25 centimeters. And the very final one will be UAVs at 5 centimeters. I couldn't even represent that on the map. It will just be a little dot. So you can see we have all these spatial scales. And depending on what you want to look at in the environment, we can use these different satellites. So if you wanted to look at drainage, the 500-meter satellite would be no good. You wouldn't be able to see anything. That's only really good for looking at large scale land use change, like if we're going to plant a forest over a large area. So we have all these tools at our disposal to look at the landscape at different scales. So I'm going to go through that a little bit and discuss each different type. So in my research, I've used them all, and they're all available tools for me. And this piece of research here was focused on the blanket bogs, looking at disturbance on the blanket bogs up in the Wicklow Mountains. We used the MODIS 500-meter spatial resolution. So that's the pixel size is 500 meters. So it's very good for detecting large-scale disturbance events. And by disturbance, I mean disturbance or degradation to the peatlands. So forestry will be classified as that in this context. Burning of the peatlands will be classified as that. So it's anything that changes the peatlands. And you can see that it's quite good at picking up large-scale degradation. So fires and forestry plantations or forestry being removed as well. Then we move to a much lower, much finer spatial scale. So this is the India remote sensing. So this is work that I did and was published in 2018, which was I presented this to you earlier on. So in this, we're able to see a bit more detail and look at the grasslands, the forestry, industrial peatland and residual peatland, and understand what it is doing over time. And when we move on to the next one, it's around the same resolution, 30-meter spatial resolution with Landsat. And with the Landsat data, because the record goes back to 1984, we can look at these land use dynamics in the landscape. So this is Wahaj's work, where he creates this fantastic animation that shows that land use change over time. We then have the European Space Agency Sentinel-2 satellite, which is at 10-meter spatial resolution. And now we're able to look in a bit more detail into land units. It's still quite you're not going to get in massive fine information, but it's pretty good. You can look at, so this is a peatland area in the Midlands, and you can see the Shannon on the top left corner there. The green areas are grasslands, and then you have the red areas are the industrial peatlands and they're beginning to undergo this kind of restoration process. So within there, you can see pink lines almost, and you can see the blue areas. And these are areas, so the blue is standing water, the pink is this peatland vegetation coming back in. So you see it's coming back in the block drain. So you're able to monitor this over time. And then the dark green areas are forestry. And the finer resolution you go, the more accurate the imagery is. Then we can go to the next level up, which is looking at high resolution satellite data. So between 50 centimeters to 3 meters. And in this, we can start to identify and classify and map different vegetation types. So this is the Fawcett vegetation classification system. So you can see in there we've wet heath, dry heath, blanket bog, bracken, eroding peat surfaces. We've grassland in there as well. So we can start to identify and detect these on the landscape. And this is a very important level for us to look at to see how we can say in the Wicklow Mountains, there's a lot of restoration happening up there now by the National Parks and Wildlife Service. So we can start to monitor that stuff over time. How effective is it? Then we go we can even at this spatial resolution start to look at drainage maps on the landscape. So we can detect the drains and map the drains. And this is actually quite a difficult process to do, to get the computer to see these features. But at this kind of high resolution data, we can start to really detect those drains at a really good spatial scale. This is work I did in 2017, where it was kind of like a pilot study where I detected 500 kilometers of drains. But then in the Smart Bog project that's just ending up, my PhD student Wahaj again worked on extending this out to 6,500 square kilometers in the Midlands, really focused on the raised bogs. And in his work, he detected about 18,000 kilometers of drains. So the A and B show drain density, with the red areas being up to about 400 meters of drains per 100 square meters. And then the other maps, C, D, E, and F, show the actual individual drains. Now, when you're zoomed out, it just looks like a blob of data, but there's actually individual drains identified there. And this is an example of that, that detail there. So on the Bord na Móna land, you can really see the drains really effectively. And then on areas where it's been cut over, it also picks out that kind of drainage there as well. Okay, so I'm just going to talk a little bit about some other relevant research that's ongoing. So DTEC just started last year. The Smart Bog is just finishing up. iHabimap has just finished up as well. The Co-Centre for Climate, Biodiversity and Water is a large-scale project between Ireland, Northern Ireland, and the UK that just started up last year, and then a couple of lines on the Iconics project as well. So the DTEC project is a project that's run from Teagasc. Professor Owen Fenton and Dr. Pat Toohey are the PIs on the project. And it's basically, we need to understand the drainage status of grasslands on organic rich soils. So the project is aiming to look at that. And we're using a combination of drones and satellite data to look at that. So on the top right-hand side, you can see the drone that we're using. Quite sophisticated piece of machinery. But we're interested in looking at mapping the drainage status of grasslands using high-resolution remote sensing data, ground-based measurements, and machine learning techniques. So we have several farms that we're working on across Ireland. So we've one in Kerry, we've one in the Midlands as well, and we're putting in a lot of instrumentation. So at the moment, there's a lot of instrumentation going into these farms. There's a lot of dip wells being installed, and the guys on the ground are doing absolutely Trojan work. So in terms of the drone surveys, you can see some of the instrumentation here. There's really high resolution cameras, multispectral cameras. The one in the middle that looks a bit like the spider's eye or something like that. On the right hand side, we have LiDAR data, so we're recording the topography, the micro topography in the fields, and we're trying to relate the signatures we get from the camera with the micro topography to see if we can detect infield drainage or subsurface drainage. So this is one of our field sites down in Lyra Crumpain, down in Kerry. And you can see it's quite an extensive area. With the drone, we're able to get the elevation data, and you're able to pick up some features in the landscape there, so you can pick out field boundaries and drains and stuff like that. And from these data, you can create a topographic wetness index, which gives you an overall idea of where the water is flowing in the landscape, and that comes out of the LiDAR data. Also, we're interested in using the camera to look and classify different types of grasslands. So this is a site from Glenismole in Dublin, from a farm in that area. It's kind of an upland farm, and we're using these kind of instruments to look at the different types of grasslands that are located on that particular farm. So you can see there's dry grasslands, there's wet grasslands, and where they are found in that farm. So this is very kind of cutting edge stuff that we've worked on this project, and it's something that could potentially be rolled out more broadly. And then you can see this instrument also has a thermal band on it, so you can see the wet and the dry areas in relation to the thermal signature, or how hot or cold they are. So we're hoping to use that sensor to be able to detect subsurface drains. So it's kind of out there stuff, and we're not sure if it will work yet, but we'll just see how it goes. Okay. The guys on the ground have done amazing work. So the Teagasc guys have done peat coring right across the area. This is really heavy going. So they've measured the peat depth right across the site as well. And you can see how peat depth varies from the white dots, which are about up to 50 centimeters, right up to the darker red and the brown dots, which are greater than 2 meters in depth. So this site contains quite a lot of peat, probably in the thousands of tons of peat, particularly in the deeper areas. And on the right hand side, you can see one of my postdocs, Louis, with the kind of rods that we use to measure peat depth. And then when we get this measurement of peat depth, we can then create these peat depth maps, which illustrate the depth of peat right across the site. Another way of monitoring is to use that high resolution data. So we're using the Sentinel-2 data here, which is really useful for identifying managed wetlands across the landscape. So this is just a snippet of the work that was done across the raised bogs in Ireland, so across the Midlands areas, to classify the land use on the peat soils. Again, this is the data that I mentioned earlier on from the high resolution satellite imagery at 3-meter spatial resolution. So this work has been published at this stage, and this work was only done for this area here, and this is something that could be rolled across all the upland areas in Ireland. Again, this is the work that was done on the Smart Bog project, and this work is now being applied to this project here. So it's a project that's on the co-center for climate plus biodiversity plus water. So I have a new PhD student who's one of her tasks is upscaling these drain mapping techniques right across the country, and we're in the very, very preliminary stages of doing this. Some of the very preliminary results look very positive, so we're hopeful that this will be something that we can do. Another aspect of the project is looking at the carbon fluxes from this upland area. So this is a Teagasc NASCO tower up in the Wicklow Mountains, which is fantastic. We don't have that much data about what's going on in those upland peatlands. So to capture this kind of data is really, really useful. And then it's going to be used with satellite data and high resolution drone data to try to understand what kind of vegetation is occurring here in this area here, there's a huge issue with deer, and there's a massive overpopulation of deer in the Wicklow Mountains, and it's causing a lot of degradation to the vegetation and trampling of the ground itself. So it's very interesting to see if we can pick that up, that degradation with the flux tower. Just some future research. So Dave O'Leary, who works at Teagasc now, I think, and Eve Daly, who's at University of Galway. We worked on using radiometrics, which measures a radioactive decay from the rocks underneath the landscape. And what you're measuring is the signal gets attenuated or reduced when it's wet. So they're able to map wet areas or peatland areas using their techniques. So the next stage of the Irish peat soil map will incorporate their data, and will also incorporate data from the bog commissioners maps. And then I have another project in mind is peat depth mapping. So we really need to understand how much peat is on the landscape in particular areas. And maybe I'll be coming back to the audience here to ask for help with this project in the future. So just some acknowledgements. So I've had, not all this work is my work. I've collaborated widely with people across different universities across Teagasc. So as DCU, University of Galway, Teagasc Research Ireland has funded the work, Department of Agriculture, Food and Marine, and the EPA have also funded the work. So, and thank you all for coming to listen to me today.
Thanks very much, John. Great interest in that your presentation today, and it really tells the story of the how peats have evolved in Ireland and those changes. I suppose responding to policy, I'm sure over the years, and demands on agriculture and so on. I mean, that's quite an astonishing figure there. 33% of the total soil organic carbon is in peatlands. And I know that Ireland has quite a lot of peatland. You know, how special is it compared to at a global level?
What do you mean, how special?
So what I mean is, you know, in terms of the amount of peatland that is across the world, you know, what level or what percentage, or you know, what countries would typically have the more peatlands? I know you
Yeah,
talked
so
about the Amazonian types of peats,
yeah, so yeah,
carbon.
in Amazon, in the tropical zones there are a lot of peats, but the main peatland extent globally is in the northern latitudes. So
Mm.
if you look at Canada, they have a huge percentage of peat. So about 14% of Canada is covered in peatland. Um, for example, they have one area called the Hudson Bay Lowlands, where one peatland complex covers about 280,000 square kilometers. So massive areas of peat across Russia. Russia, like basically Siberia, is mostly just peatland. So in terms of, in terms of the global area, Irish peatlands are very, very small. But in terms of Ireland, they're very significant.
Yes, 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 absolutely. Catherine, I think we should get straight into the questions because there's lots coming there.
Yeah, very serious interest in it, as you said, Mark.
Mm,
And I just to say, from my own point of view, I really welcome the work and the focus on the uplands. Coming from the biodiversity point of view, there's a lot going on in the biodiversity world, and I think all the work that John is doing and all the work that's going on will all come together and needs to, but it's fantastic. It will be a huge support, I think, to the habitat work.
mhm.
Couple of specific questions, John. How does resolution, as in meters, compare with scale? To scale, one is to 5,000, etc. So resolution versus scale.
Yeah, I that's something that always, I always get a bit stuck in that. So if you're looking at the old maps, like the Hammond Peat map, I think it's 1 to 575,000. That's the scale. But how does that relate to the resolution on the ground? Um, Basically, when you have a larger, so that's a small scale map. A large scale map would be 1 to 1,000 or something like that. So the larger scale maps um, are finer resolution. So something like the Hammond map at 1 to 575,000 would be relatively coarse scale. There's no, it's hard to kind of relate the two. They're kind of different
Yeah.
concepts in a way, so it's hard to kind of relate the two. But if you have a large scale map at 1 to 1,000 or 1 to 10,000, it would relate closer to the finer scale imagery, if that makes sense.
Yeah, yeah. Regarding the grass on peat, with 2 meters peat remaining, what is estimate of peat loss, or is peat loss lower on grassland?
So it depends on what the drainage regime is in the particular field. So if the drains are deep drains, so around the edge, if the drains are 2 meter deep, then the the peat soil in those areas will be more exposed to oxygen. Okay, so where you've deeper drainage, you get more greenhouse gas emissions. And basically how that works is that it's a really simple idea, right? And what causes the greenhouse gas emissions is the bacteria in the soil. Okay. So in a wet peatland, the amount of bacteria that can survive in that are really small because it's really low in oxygen. So it's an anaerobic system. Once you drain down the water, the peat becomes aerobic, so there's much more oxygen in the soil, and that much more oxygen can support about 10,000 times more bacteria. So that's what causes the decomposition of the peat is the bacteria are eating the peat and they're releasing CO2. So when you lower the water table, you're just creating an environment for more bacteria to come in and decompose the peat.
Very good. Would Derby wetland, approximately 1 meter deep, sequester carbon to the same degree as peatland?
What's Dobby wet? I don't know what
You know, kind of, how would you describe it? It's a word I'd be familiar with, Mark.
Daub, yeah.
Uh, very
Marley.
fine, yeah.
Uh,
so. I'm
Heavy
like
land.
it depends on the vegetation that is in that system and how high the water table is in the system. So like I'm not familiar with that
Yeah,
landscape, so I'm not entirely sure. But
yeah. I think it's different, very different to peatland, isn't it,
yeah,
Mark? So it would be,
and yes, it can, I suppose, underlie peatland as well, or maybe previous older peats as well.
yeah. A couple of more specific questions. Where can people get a link to the GIS peat maps?
yes, they are. So our peat maps are all freely available. So we're we they can get them through me, but I think I there is a website that they're available on, so maybe I'll share that with you, and it can be shared more generally rather than emailing me because that's adds to my workload.
Exactly, yes. Can the methodology applied be used to generate a national habitat map? What would be the effort involved? And were the county wetland surveys of use in your study?
So the last one, yes, we used wetland surveys from the Monaghan region
Mhm.
because that was one area we identified that was we had a lack of ground truth data for that area, so we did use the county survey for that particular one. I think more broadly, I can't remember if we did, but we did it. But when we produce our map, we have to get ground truth data, and because there's only two of us working on it, we can't go out and survey everywhere. So we're reaching out to loads of different organizations to get their ground truth data in. So maybe in that process we did I'm not my postdoc would know the answer to that.
And the question there, can the methodology applied be used to generate a national habitat map?
So the methodology that we used combined the methodology for creating is it for the peatland map? I'll assume it is. So the
Yeah.
methodology that we used to create the peatland map um, is a combination of different maps. So what we do is we combine different maps, and basically we have a rule that says if at a particular location, it more than two sources say that it's peat, then we classify it initially as peat, and then we use our ground truth data sources to go out and look at those areas to see how accurate our classification is.
Mhm.
Um,
Mhm.
and
Yeah.
like if you're looking at habitats, then you're looking at many different habitats. So I think you'd have to really think strongly about how you would do that with the sources that we have.
It's not an automatic link. Sure, it's not, because as you said, you can have different habitats on top, I presume.
Yeah, different habitats. Like maybe with the national land cover map,
Mhm.
that'd be a better kind of way to start anyway.
We have some
Back,
questions here
sorry.
just on the rates of degradation. Yes, degradation that you talked about there, and thank you for explaining that so clearly because we don't always understand that effect of the anaerobic versus aerobic conditions, and it is the microbes that are actually releasing
Yeah.
that carbon. But could you give an indication of the rate of carbon loss from drained peatland under grass? Now, is this maybe getting a bit more technical, but or even if you could talk about those different types of conditions or land uses that would, reduce that loss of carbon.
Yeah, so off the top of my head now, I don't have the rate.
Hmm.
Um, Somebody who's working in with the with the flux tower data and I would have that at the touch of their finger.
Yes. Yeah.
So I think the kind of rule of thumb in terms of subsidence is 1 centimeter per year in drained peatlands. Now that's subsidence, which is not necessarily emissions. You could just
Okay.
take the water out and it could just collapse. But in terms of emissions, I don't have that number off the top of my head.
And just while I have you there, you talked about the different sources of information that you're using to correlate to try and understand the existence of peat in an area. Have you been using any sort of sources, folklore sources, place names, or archaeological information? That's a question come in from Mayo, I suspect.
No, we haven't. We've mainly used there's kind of four main sources that we use. We use the Corrine data.
Mhm.
We use Hammond's peatland map. We use then a combination of the quaternary soils map and the soil information system. So it's a combination of those. And then going forward, we'll then use again we'll bring in the bog commissioners maps in the next iteration, and we'll bring in the work that Dave O'Leary has done on the radiometric assessment of the landscape. So yeah, I think that's using place names is something that as a geographer is really, really interesting to me because a lot
Mhm.
of place
Mhm.
names really describe the landscape, like
Mhm.
the term Inish, the name
Mhm.
Inish is island, and often in the Midlands you see places called Inish and there's no island around, but it kind of looks back to a time when there was a lake there. It's now a raised bog, but there would have been a mineral island in the middle of it. So place names are really, really useful for that. And that's probably a whole new area of study as well to look at.
Yeah, just a couple more. Are nitrous oxide emissions from denitrifying bacteria in anaerobic conditions in peat a concern?
That's beyond my expertise
Yes.
here. I
Yeah.
think there's other people who'd be much better placed to answer that. And I'm sorry for saying that. I know that people are like,
No,
oh, he
no.
should know everything, but I don't know that. But I think nitrous
I
oxide
think
is a
I
it,
think you know lots, lots of policy ones there, which again, I suppose, yeah, what's the effect of all this on policy? I don't know. Have you a comment or thought about that?
well, we have showed this information to policymakers. I think that back about 5 or 6 years ago, the work informed the Board Namona PCAS system, the Peatland Climate Action Scheme. Um, we have had discussions with Department of Agriculture. They're very aware of our work, with the Department of Environment, with the EPA, with the NPWS. Now, I haven't. I'm sure it is influencing policy in some way, but I'm not privy to that information or those discussions. So,
Yeah,
the government is funding our work through the EPA, through Department of Agriculture, through
Mhm.
SFI. So, it's up to then the policymakers to take the work on or not in the future. And I don't
yeah,
know how that will go.
Yeah, so we'd had some questions there just on the technology side of things, and the opportunity for AI in this whole area. Do you see AI being able to help us monitor those changes and even help with identification of peatlands through whatever imagery that we're capturing along the way?
Yeah. we've already used AI in some of the work that we've done already. We've used AI, so some of the mapping work that we've done, we've used machine learning, and there's different types of machine learning, which is all comes under the AI umbrella.
Sure.
So that with the extensive drain mapping that we used, looking at the Midlands, machine learning was used in that process. Some of the high resolution mapping of the uplands, machine learning was used in that process as well. And then there's other projects that I'm aware of. In out of UCD, there's a project called Peat to AI, I think it's called, or AI for Peat. They're doing extensive work on the Midland raised bogs, and they're really using AI to map ecotopes or vegetation assemblages on the peatlands. So, going forward, we're going to have to incorporate AI. AI is a very useful tool to help us get through large amounts of data and the kind of data that we need on the landscape. If you're using the coarse resolution MODIS data, that's you can kind of do that manually more or less. But if you're trying to, use high resolution aerial data or satellite data or drone data at 5 or 6 centimeters, then the amount of data that we would collect out of one flight, gigabytes of data, to
Yeah.
process that, we need machine learning to help us to do that. So yes, I see it being integral to the future of monitoring, basically.
Yeah, it is quite extraordinary the evolution in technology, even the last few years, and that drone technology, and so it's brilliant. It's brilliant. Sure, makes all our jobs a little bit easier. So, John, we're out of time, unfortunately. We've got through most of the questions. We had to cluster a few of them. Thanks to everybody for their questions and their engagement this morning. Catherine, thanks for helping with questions. And John, we'll hopefully keep in touch with you on that work, and maybe you could come back and give us an update on some of the work that you've been doing in the future. We'd really appreciate that.
I really enjoy that.
So thanks again. Just to let everyone know that we'll be joined by Flo Blackburn, who's the manager of the Curlew Action in UK, and we'll be discussing action now for curlews tomorrow and other species. So do join us next Friday for that. In the meantime, thanks again for joining us today, and today's session will be available in the coming days on our Teagasc YouTube channel and podcast channels, whichever platform you use, and we'll have a copy of John's presentation available also to download. So John, once again, thanks again, and look, we will talk to everybody again next Friday. You've been listening to the podcast version of the Teagasc Signpost Series, the weekly webinar that promotes and examines sustainability in Irish farming. Don't forget to join us live every Friday morning for our latest webinar. For more, visit teagasc.ie. And you can also rate, review, and subscribe to the Signpost Series on Apple Podcasts, Spotify, or wherever you get your podcasts from. I'm Mark Gibson, and thanks for listening.